Hello. Here I will cover topics from DeMoivre's theorem. We let I equal the imaginary number square root of -1. Now note, I squared is equal to square root of -1 squared, which is -1. So what we have, I squared equals -1, so we have an I. If you square both sides, we have I squared is equal to -1. And then if we multiply both sides by I, we have I cubed is equal to -I. And then if we multiply both sides by I again, we have I to the fourth is equal to -I squared. But we see that I squared is -1. So I fourth is equal to -1. And that tells us that I to the fourth is equal to a +1. This forms a group. We're not going to go into that now. Something else with I. Your complex numbers are shown as a boldface C. And this is where A and B are elements of the reals. So we have we also have we have this for the complex numbers, A and B. A is like your X, B is like your Y, if you like. When we graph them, we'll be graphing them here in a little bit. Here, your R is called your modulus. And we also have getting us into the DeMoivre's theorem, the trigonometric or the polar form of the complex number Z is going to be R times cosine theta plus I sine theta. Multiplication and division of complex numbers. So if Z1 is equal to R1 times cosine alpha plus I sine alpha, and if Z2 is equal to R2 times cosine beta plus I sine beta, then when you multiply the two together, you have R1 times R2 times all of this item times all of this item. But look what happens here. Cosine alpha times cosine beta, and then plus I cosine alpha sine beta, and then plus I cosine beta sine alpha, and then here we have plus I squared sine alpha sine beta. But I squared is -1. So since I squared is -1, that turns this into a minus. Okay. Combine like terms, we have cosine alpha, cosine beta, minus sine alpha, sine beta. And then plus, here we can factor an I out. cosine alpha, sine beta, sine alpha, cosine beta. Okay, now this looks like your sum and difference formulas. And so this cosine alpha, cosine beta minus sine alpha, sine beta, this is cosine alpha plus beta. Cosine alpha, sine beta plus sine alpha, cosine beta, that is sine alpha plus beta. So when you're multiplying z1 times z2, it's going to be the moduli multiplied, and then it's going to be cosine sum of the angles since you're multiplying, plus I sine sum of your angles if you're multiplying. Okay. And then similarly, if you are dividing z1 by z2, you will divide the moduli, and then you're going to be subtracting the angles for the cosine and subtracting the angles for the sine. One way to see this is that multiplication is repeated addition and division is repeated subtraction. Another concept, if we let z equal r times cosine theta plus I sine theta, if we were to compute z squared, that is, we need to find r cosine theta plus I sine theta times the same value, r cosine theta plus I sine theta. You will multiply the moduli, giving you r squared, and then as r squared times, here we need to add the angles for the cosine and then add the angles for the sine. So we have r squared times cosine 2 theta plus I sine 2 theta. And then if we to compute z cubed is just z squared times a z. So since this is z squared, it's this times z. And again, we're going to multiply the moduli. And then for the cosine, we're going to add the angles. 2 theta plus 1 theta is 3 theta. Same thing with the sine. We're going to add the angles. 2 theta plus 1 theta is 3 theta. And this gets us into DeMoivre's theorem. So here, we're going to let n be an element of the natural numbers. What that is, your natural numbers, these are defined as, they start at 1, 2, 3, 4, and they go up to infinity. No fractions, no negatives, no zero. So those are your natural numbers. So if that's the case, r times cosine theta plus sine theta raised to the n exponent is equal to the modulus to the n exponent, and then cosine times the n exponent times your angle plus I sine n times your angle. So plot each point in the complex plane. So your vertical axis usually has been labeled the y-axis, but here we're going to look at it as the I-axis. So this is the I and this is the x. So that the point 4 minus 2i is going to be 4 units in the horizontal direction, x1, and then 2 units down. So that is the point 4 minus 2i. Okay. It's a little bit unusual at first, but so this point, negative 3 minus 5i, 3 in the negative x direction and the negative 5 in the y direction. Okay. To plot I, well, I is the same thing as 0 plus 1I. So to plot 1 on the complex plane, 1 is the same thing as 1 plus 0I. Convert each complex number to rectangular form. Okay. So this is the same thing as cosine of 5 pi over 3. That's going to be 1/2. And sine of 5 pi over 3 is a negative radical 3 over 2. So when I distribute the 6, I will have 3 minus I radical 3. Technically, this is the proper way to do it in A plus BI form, because there's your A and your BI. Personally, I like to put the I in front of the radical just to emphasize that the I is not under the radical. The I is separate. Either way is fine. Okay, so this is 3 times cosine of 3 pi over 2 is 0. And then plus, we have I times sine of 3 pi over 2 is negative 1. So this is equal to negative 3I. All right, so here we have 1/2 times cosine of 240 degrees is negative 1/2. And then plus I times sine of 240 degrees is negative radical 3 over 2. Okay, so this will give me negative 1/4 minus radical 3 over 4 with an I. Okay, so this is equal to 5 times cosine of pi is negative 1 plus I times sine of pi is 0. Okay, so for here, I'll use a half angle formula. pi over 8 is the same thing as pi over 4 times 1/2. This is 1 angle divided by 2, a half angle formula. Pi over 8 happens in quadrant 1, so we will use the principal square roots with these. Okay. Actually, it's pi over 4. Cosine of pi over 4 is radical 2 over 2. So you have radical 2 over 2 plus 1 is the same thing as 2 plus radical 2 all divided by 2. And then this whole numerator dividing by 2 is the same thing as the whole numerator times 1/2. To do the same thing over here. So this will give me a 4 in the denominator of the radical, so that when I take the square root of that, you get a 2. I forgot to include the 1/2 over here. So that now when I multiply this 2n, the denominators simplify, and I'm left with Thank you very much. Please go to tutoring.